So yesterday we learned about solving one-step equations. Today we're going to take that idea and just add a little bit to it and do two-step equations. Here's our first example. So this has two steps. And what we're doing is we're really doing order of operations backwards. So here we have two things going on. We have multiplication and we have parentheses. Well, parentheses is last. If we go backwards, so the first thing we'll do is multiplication, and then we'll do our parentheses. So we're multiplying 7. What is the inverse of multiplying? Dividing. So we divide 7 by both sides. Our new equation, which I'll write over here, is k minus 6 in parentheses equals 42 divided by 7, which is 6. Now we can drop these parentheses because there's nothing else around them. K minus 6 equals 6. And now we're subtracting from k. What's the inverse of subtracting? Adding. So we add, and we end up with k equals 12. Example 2. Even though there's not parentheses around this top portion, because the entire thing's being divided, we could put parentheses around it. So we're going to assume that there are parentheses around this top portion, and we're going to do order of operations backwards. So before we can do parentheses, we have to do multiplication or division. We're dividing by 3. What's the inverse of dividing by 3? Multiplying by 3. So we multiply both sides by 3. And we end up with negative 1 plus n, and again I'm going to drop the parentheses because it's no longer being divided, equals negative 5 times 3, which is negative 15. Now what else is happening to n? Well, it's being added to negative 1, so we have negative 1 plus n. So in order to get rid of that, we will add 1. Or you could call this subtracting a positive 1. It's the same idea. We're going to add 1 to both sides. 1 minus 1 is 0. So these terms are gone. And we have n equals negative 15 plus 1. So n equals negative 14. Example 3. Again, we're doing order of operations backwards. We don't have parentheses this time. We have multiplication and we have addition. So if we're doing order of operations backwards, what comes first? Multiplication or addition? Again, we're going backwards. Well, that means addition comes first, okay? So we're going to undo addition. The inverse of adding is subtracting. So we're going to go ahead and subtract 8 from both sides. And we get negative 9a equals negative 63. Now we can divide by negative 9, because we're multiplying by negative 9. The inverse is to divide. We divide by negative 9. A negative divided by a negative is some positive number. 63 divided by 9 is 7. So our answer is 7. Again, we're doing order of operations backwards. We have multiplication and subtraction. Subtraction comes before multiplication when we're going backwards. So the inverse of subtraction is addition. We'll add 5 to both sides. And we end up with 170 equals 10n. We're multiplying by 10. The inverse is to divide. We divide by 10. 170 divided by 10 is 17. In our next example, this is actually an error, so we're going to change the way that this example looks. And, well, why don't we just do this? Let's just skip this example because obviously there's an error in it. Okay, next example, we have addition and multiplication. We're doing order of operations backwards. So we're going to do addition first. What's the inverse of adding? subtracting. 20 minus 4 is 16. So we have 16 equals negative 2a. We go ahead and divide by negative 2, because we're multiplying, negative 2 times a, so the inverse of multiplying is dividing. And we end up with 16 divided by negative 2, which is negative 8. In our next example, we have addition and division, so we'll do addition first. The inverse of adding 1 is subtracting 1. So that gives us 4 equals x over 4. The inverse of division is multiplication. 4 divided by 4 is 1, and we're left with x. 4 times 4 is 16. Again, order of operations backwards. First we subtract 6 because it's the inverse of adding 6. We have negative 6 plus 1, or 1 minus 6, which is negative 5, equals negative a. This is kind of tricky because you don't see a number, but there's actually an invisible 1 here. So negative 1a. We have 1a here. That's why there's no number, because we already have 1. Negative 1a, so we divide by negative 1. Negative 5 divided by negative 1, positive 5. Again, we'll do order of operations backwards, so we'll begin by adding 4. And we have x over 3, or x divided by 3, equals negative 7 plus 4, which is negative 3. And then we'll multiply both sides by 3. Negative 3 times 3 is negative 9. This is our last one. Again, we have this addition here of 1, so we'll subtract 1 from both sides. And we end up with negative 10. Remember, I have to keep that sign. Negative 10m equals 11 minus 1, which is 10. I'm multiplying by negative 10, so I can divide by it. And m equals negative 1. Good luck. Again, this is just like one-step equations, except we're adding that second step. So rather than just multiplying, or just dividing, or just adding, or just subtracting, we're doing a couple of things. So we'll divide, and then we'll subtract, or we'll add, and then we'll divide, or we'll add, and then we'll multiply. So it's just 2 steps now instead of 1.